In this chapter, we're going to take a little time to kind of examine what are perimeters. Specifically, the intent is to kind of understand how the geometers of the classical age kind of went about trying to find perimeters of various shapes. Okay. First off, one of their most important results was that the circumference of a circle was equal to 2 pi r. It was inherently directly related to the radius. Okay. The diameter, of course, being the equivalent of 2r. So you could say it was c, the circumference, was proportional to the diameter, or it was proportional to r. It does not matter. They mean the same thing in this case. Okay. This was already known well before Archimedes. This was known to the ancient Egyptians, the Babylonians, and the ancient Indians as well, that there was such a relationship. But this relationship was predicated on knowledge of some particular value of this unknown constant that we call pi. They knew that there was a relationship to it, but they couldn't establish exactly what the number is. And in fact, there is no way to exactly establish what that number is. It is an irrational number, which means that it's the amount of digits it carries continue well beyond countable. It's an infinite number of digits after the decimal point. Okay? But many attempts were made to actually calculate their circumference. And here we're going to describe just a little bit of how they approximately did so. One of the ways is to look and say, okay, we can get a good estimate of the perimeter of a circle just by saying, okay, the perimeter of something inside the circle is known. So, starting with a circle, just all the way around, okay, sweeping all the way about, we have, of course, a circle. We could inherently draw whatever we're kind of interested in, but let's choose shapes that are real easy to calculate things. Okay? The first shape, of course, the simplest polygon that they can choose, would be a triangle. Okay? And as you measure the triangle, we can just say that, let me connect it here. We can connect the edges to these points. And create a triangle just on the inside. This is what's known as an inscribed triangle. Okay? A triangle is inscribed inside the circle. Okay? This is approximately an equilateral triangle. But what do we notice? The perimeter, okay, the addition of all the side lengths of this triangle, are going to be slightly less than the total perimeter of the circle. How do we know this? Well, the shortest distance between 2 points is the straight line. This, of course, is not a straight line to the same 2 points, so therefore this is a bit longer. Okay? Now, to improve upon this, what do? Well, you make the total distance much closer. I mean, you can see this spreads out. This curve is very far away from this edge. So we just start making more and more sided polygons that we're going to inscribe inside the circle. Okay. The next one that we can do is a rectangle or a square. Square is preferred, but we will create one now. Okay. Or an approximate one. Since we're not actually calculating, we're being very rigorous with this, we're not going to worry too terribly about being perfect, but instead worry about getting the general idea of what's going on. So in this shape, we have created now a square that is inscribed in the circle. Okay? Notice that this one is not nearly as far. The farthest distance away from the square to the circle is from here to here, which is a little bit shorter than this distance, which is the distance away from the triangle. Each time we increase the number of sides, that distance shrinks. The more that distance shrinks, the better the estimate of the actual perimeter. Okay? This is also a way to estimate the area of the circle. So they can keep on going. You can create all sorts of higher order objects. They become more difficult to just draw freehand. But we also have a diagram of what these end up looking like, which we will show now.